Here's a standard weapon. The alternative, within seconds, is easily mounted to the top of the weapon. There's no obstruction to the sight picture for the operator, and there's no obstruction to the functionality of the weapon or the rail system. It still allows an officer the ability to attach a flashlight on their weapon. Once the weapon is fired, the bullet travels down the barrel, embedding itself inside the alloy projectile with no chance of escaping, instantly becoming one solid unit. The projectile immediately separates from the weapon, as the docking unit is instantly ejected. Then, a new bullet is cycled in for follow-up shots if necessary. The alternative is as accurate as the operator using it. Once the projectile impacts the threat, it will send a shockwave of pain to the suspect without the internal damage that a penetrating bullet would cause.
Hi, my name's Tony Lettieri. I'm a retired homicide detective from the North Las Vegas Police Department. Prior to that, I was a deputy sheriff with the Nye County Sheriff's Office. During my time in homicide, I investigated every type of violent crimes, including officer-involved shootings. I was also a department training officer, field training officer, K-9 officer, and I was on a tactical team. Today, I want to introduce you to the alternative. Let me show you how it works. You're on a scene, and it's been determined that a less lethal is the proper deployment for this situation. You have the suspect in your sights, and you retrieve the alternative from the pouch. You place the alternative on the slide of your weapon. Prior to deployment, you're going to announce so that other officers in the area know that this is a less lethal deployment. And you shout, less lethal, and fire. Now the subject can be taken safely into custody. As you can see, the bullet safely embeds itself inside the projectile, as the kinetic energy of the bullet takes the projectile downrange at about 20% of the speed of a normal bullet. Here you can see the projectile cut in half and shows the melding of the bullet into the projectile. When it hits, it sends a shock wave of pain to the suspect, more than likely putting the suspect on the ground. And it's as accurate as the officer shooting it. The alternative may be an option if the suspect has, for example, a knife, a screwdriver, a broken bottle, a bat or a club, or anything that could be a possible threat to the officer's safety. Let's run through this one more time. I remove my weapon, focus on the suspect, remove the alternative from the pouch, place the alternative on my weapon, announce, less lethal, less lethal. Now the suspect can be taken into custody. Police officers make decisions on when to use lethal force in accordance with their department policy. Up until now, the choices were limited and not always effective. Now we have the alternative.
Here's a standard weapon. The alternative, within seconds, is easily mounted to the top of the weapon. There's no obstruction to the sight picture for the operator, and there's no obstruction to the functionality of the weapon or the rail system. It still allows an officer the ability to attach a flashlight on their weapon. Once the weapon is fired, the bullet travels down the barrel, embedding itself inside the alloy projectile with no chance of escaping, instantly becoming one solid unit. The projectile immediately separates from the weapon, as the docking unit is instantly ejected. Then, a new bullet is cycled in for follow-up shots if necessary. The alternative is as accurate as the operator using it. Once the projectile impacts the threat, it will send a shockwave of pain to the suspect without the internal damage that a penetrating bullet would cause.
All testing was performed at our Chesapeake facility in Belcamp, Maryland, in an indoor climate-controlled range. All of our ranges are NIJ approved. All the equipment used was calibrated per NIST standards. Some of the equipment that we used to conduct this testing included Doppler radar to measure the projectile velocity, high-speed video cameras to help characterize the impact performance of the projectile. In addition, all testing was performed with a live firearm. In this case, a Glock 17 9mm was used. The round that was used to fire out of the firearm was a Spear Gold Dot Hollow Point 124 grain plus P 9mm round. The device was fitted to the end of the firearm device as it would be in a real-world application for all shots.
Hot!
For the ASTM testing that we conducted, we tested in two scenarios, one with the target at 21 feet and one with the target at 32 feet. The CEP for the target at 21 feet was 3.3 inches, and the CEP for the target at 32 feet was 4.5 inches. The CEP is defined as the diameter of a circle centered about the mean X and Y impact values, whose boundary is predicted to include 90% of the projectile impact locations for the same testing parameters and setup. The second test that we performed was a series of gelatin tests in which we covered the gelatin with a skin simulant and evaluated the penetration characteristics of this device.
Fire hot!
After each shot during the penetration assessment testing, we would measure the laceration lengths and characteristics of the laceration on the foam and the chamois material that was covering the gelatin. While at the same time, we also measured the impact velocity and resultant impact energy for each shot. The third test that we performed was in accordance with NIJ 0101.06, which is the current industry standard for NIJ law enforcement body armor. In this test, we tested various clothing materials which were strapped to a clay backing. The clay backing was in accordance with the NIJ performance standard.
Good. Good.
Following each shot, the clay was evaluated to see if the projectile penetrated the clothing material, and if not, the deformation that was left into the clay backing as a result of the material stopping the projectile. What my team and I observed during the testing is that when the bullet was fired from the handgun, the bullet would embed into the projectile of the alternative, and then that combined system would travel downrange and impact the target of interest. When we first saw the device, we were unsure of how it worked and how it would perform under testing scenarios, but after working through a day and a half of testing, it was very accurate at distances of 21 and 32 feet. The velocity was very consistent, for each shot. Now that testing has been concluded, we'll collaborate with our colleagues at NTS Dana Point to analyze the data, to draw any conclusions that are there for us, and we will issue a final report to Alternative Ballistics.